I created a compute shader to generate marching cube terrain in the last video, so I decided to play around some more with compute shaders on stream. It was pretty chaotic and led to some cool results, so stick around and enjoy the video. Yeah, sorry, it kind of like disappeared for a while. We're back though. Yeah, this is the compute shader. This is what I've been working on. Why is this solution explorer on this side? I don't know. Wait, where did it go? Okay, this is too complicated for me. Can we go back to scratch? All right, yeah, I'll do that. I wanted to just like mess around with compute shaders some more. So yeah, let's just like make random compute shaders. So basic compute shader stuff, okay? So we've got, this is our kernel. This is like what is running. So that's this function here. So pretty simple stuff. We just output a color and that's it. That's what this does. So let's make something more interesting. id.x, that width, and this, that height, like that. Oh, that just makes it yellow. And it was all yellow. Float to mouse position if id.xy is equal to mouse pause. If that's the case, then we just do 1 1 1 1, and if it's not the case, then we'll do 0. Oh, it is functioning technically. You can, it is kind of hard to see. I want to get a distance length of id.xy, and then if this from mouse is less than, I don't know, we'll do 10. It somewhat worked, only in one direction, I think. We'll make this a little bit bigger. We'll make it like 50. Go to YouTube if you're talking about the stream not working, because Twitch just doesn't feel like functioning right now. It is well, it's working for you and you alone. I don't know what's going on. I don't know why it does that. Absolute value of the length. Am I not using this function right? Oh, those are unassigned integer. Oh, yep, you're right. Int 3 id into mouse pause to xy. Can I do that? All right, well that works. Look at that. We got a circle. We can just do like resolution is equal to screen dot width, screen dot height. Yeah. All right, the resolution, this does appear to be working. Wow, look at that, it worked. Okay, and now look at that. It's accurate. All right, so we we spent 30 minutes getting a ball on the screen that follows our mouse. Yeah, let's go. So theoretically, if we would do result.id.xy. Look at that. Okay, we made Microsoft Paint. Beautiful. But if we do times 0.9f, right? Okay, well, I didn't really do what I wanted. Times 0.99. Okay. Look at that. There we go. That's pretty cool, except for the fact that it just kind of stays there after a while. Minus float for 0.1f, 0.1f. Alright, that might have been too quick. This isn't even fading out. Okay, there we go. Now it fades. Oh shoot, I'm so sorry guys. I just realized I've had this welcome thing on this entire time. That was not supposed to be there. We got like a trail effect going. So now I want to play around with something a little bit interesting. Avoid little dudes. Small creatures. uint 3 id. So now we're gonna get a whole new kernel. Small creatures. So this is gonna be a little bit different. I guess a structured buffer of float 3 creatures. So instead of using my mouse to control this, I want to make these little creatures to control this. Result id.xy creature.xy is equal to float for 1 1 1 1. So now in here we can just get like a list of creatures. Creatures I is equal to new vector 2 int random.range between 0 and resolution.x, and then another random.range between 0 and resolution.y. Theoretically, this should work. It does. All right. Again, it's really hard to see. But if I zoom in far enough, you can kind of see there are little white dots. That's about it. It's not really much to see, to be honest. Now we just need the creatures to move. Creatures id.x is equal to creature. Oh, you know what? To make it random, we have to actually like make it random. We'll make it, I don't know. I've never made like a random function before. We'll do that. Okay. So then we'll say move is equal to rand int 0 and max would be 4. So switch move. We'll do if creature.x is greater than 0, creature.x minus equal to 1. Case 1, we can just do the same thing. Then we could do some more cases using y's, and there we go. So now they all seem to just move up. So they all move up and that way. I don't know why. Maybe because my random function sucks. Why does someone go off the screen? Well, first of all, it shouldn't be less than or equal to. It should be less than. Okay, now I just gotta figure out, I need a much better random, not just this random nonsense I put together. I'm just gonna copy this dude's. Here we go. Wow, randomness. Look at that. We'll try that. Oh, that worked really well. All right, I suspect they're now just the wiggling back and forth. I don't really know, to be honest. We're gonna need to do something more robust than this, just this like dumb movement system. So what I'm gonna do is instead of doing int 2s, we're gonna do float. Let's see here, float 3, I guess. The reason why we're doing float 3s is because instead of just making it like move pixels, we're gonna give it a velocity. Oh yeah, creature plus equal to float 2. So if we have like a velocity of, like, let's say the direction here is like 1, 2, and then we do times a velocity of like 10.0 f. I don't know. They went a little off the screen pretty quickly. I think their velocity might be a little high. Yeah, look at that. Okay, so we got velocity in some sort of direction. So times delta time. Cool. All right, that works. All right, so we got that. So now let's like rotate it, I guess. I'll just say get dir vector given an angle. Return float 2 cosine of angle, sine of angle. And yes, I had to look that up. I don't know trigonometry very well. Get dir vector creature dot z, which is the angle. Look at that, it did. So then if we increase the angle is equal to angle plus 10 times delta time divided by 360. All right, so now they rotate. They rotate a little too fast. Woohoo! Alright. Plus rand of creature dot xy. So now it should rotate randomly. That doesn't really look super random though, I'm gonna be honest. Cool. It does look like it's working. So now if we just change the velocity a little bit and change the rotate, we get something that looks a little cooler. Nope, they're just going in circles again. Just kidding. Woohoo! What's happening right now? I'm making a bunch of little things that move around the screen. I don't know. Look at them. Look at them. Look at them. They're so cool. Look at that. Now there's a whole bunch of them. I actually want to make it so that if they go out of bounds, they loop around. Creature.x is greater than or equal to screen, or yeah, whatever, width. Creature.x is equal to 0. And height, of course. Look at that. Okay, so now they loop around to the other side. I think that's kind of cool. Look at that. Alright, I might have made the fade speed. I don't think the fade speed works very well. It's definitely not fading, but it does look kind of cool. No, it's fading. So here's what I want to do. Can sample some nearby points, okay? Get nearby points. Oh, I guess we could just do the float 2 points is equal to float 2 pos.x plus 1 pos.y. Well, what I want to do, so like this is a little dude, right? And he's moving like in this direction. I want to check like this space, and then he moves this space to this space is brighter, and this space to this space is brighter. But I just don't know how to do that. 0.1 plus rotate speed. 0.2 is minus rotate speed. If I maybe do move speed, and then I do 0.3 get rotate, which is just the angle. And then return -1, else return 0. All right, so now we're gonna put this in here instead. Get rotate value into creature.x, creature.z. Y. Whoa. Well, that did something. If rotate value is equal to 0 and rotate value is equal to rand, we'll try that. Wow. Okay. It doesn't really look that much different from what it was before, to be honest. This video right here. He made, like, they would make these sorts of patterns, you know? This is what I'm going for. This is what I want to make. Ah, I see. He did a lot more than what I'm doing. I don't know. But I'm missing the diffusing, I think. 2, 1, 0. Whoa. Okay. On the next live, he's going to recreate the Big Bang using shaders. It will also create a computer Big Bang. Hooray. I don't know. They don't seem to be incredibly interested. But maybe if I try the whole diffuse thing, I don't know how to do that. But, you know, I can try just being all like, what's here? Diffuse. What we're going to do, right, is we're going to get all the nearby values, okay? Total values is plus equal to result. Total values divided by equal to 9. What is it going to do? I don't even know. Bro making a 4D AI brain. Oh, well, it didn't work. Oh, you know what? I know, because I'm an idiot. Plus id.x plus id.y, and then we need to do pause.x instead of just x. I mean, it worked. Now we gotta do the whole dividing thing. That's diffusion right there, man. Look at that. Now we found a very convoluted way to generate noise. Look at that. Oh, it's beautiful looking. All right, and so then we just need to also bring it down a little bit. So we have a diffuse. So we also need, we do need the original fade as well. So this is diffuse, and then we need to do the fade. Fade. Pragma, kernel, fade. Now it should diffuse, and fade. Look at that. I don't think it's fading fast enough now. Now it's too fast. I don't know. It is cool though. It still doesn't seem to be doing what it is I want it to do. I mean, they're acting in some way, it looks like. If it's 0, they should be moving in a straight line. This is very strange. I don't know what's going on. It is a cool effect though. What if they all just started at like 0? Whoa. This is not what I was going for in the slightest, but it is cool. I do have to say. Literal smoke simulation way. So you've got some, you see, you've got some movement over here that I was kind of looking for. I don't know, like it's kind of starting to sort of work. Okay, so this is sampling a whole bunch of things. So then what we can do is say, or A, I guess, and then we can do get angle, and we can say if A is greater than angle, then return -1, else A is less than angle, then return 1, and else return 0. All right, well, that's something. Yep. All right, let's see. I'm gonna do this now. So the problem is that now they just kind of go in circles. But maybe if I set the rotate speed really low. See, I need to get them to stop rotating circles. So like if we had just one, there's a tiny little fella down there, but he's still just rotating in circles for some reason. Let's like double the movement speed real quick. It's still just rotating. Why? Stop rotating. What if I make it just like a really low rotate speed? That looks awesome. It does look kind of cool. Whoa, look at that. Whoa. Give me a minute. We're gonna need a much faster speed here. Now it just looks like permanent noise. Form patterns, please. That's all I want to do is form cool patterns. No, that's not in the center. Oh no. This isn't the center. This would be 0.25f, not 0.5f, but it is square though. I know how to do math, guys. Look at that. It's a rounded rectangle. It just like kind of explodes and implodes. It's kind of interesting. Reminds me of ant death circles. That's a rough one. Okay, well that's kind of neat looking. Whoa. Whoa. It just keeps repeating the pattern. That is kind of cool. I'm just trying to figure out what his movement code is. Wait forward, wait left, wait right. Okay, so he is doing like a forward, left, and right type of deal here. Okay, I see what he's doing. So if we kind of do sort of what I was originally doing, where we just take 3 values, right? For int x is equal to -5, x is less than or equal to 5, x plus plus. And then we do the same thing for y. We can kind of do these same checks. Value plus equal to that. Okay, so then we just return value, right? And then rotate value center right would be equal to rotate speed times delta time. So if it's right, it's going that way. If it's left, it's going that way. Okay, small creatures, yes. Peak function naming. I know, I'm really good at function naming, you know. Rotate value right is greater than rotate value left, then if rotate value right is greater than rotate value center, r is equal to rotate value right. I don't want to talk about my naming. Else rotate value center, else And then we would do left. Okay, so now, oh wait, if it's right, it would be 1. If it's center, it would be 0. If it's center, it would be 0. Left, it would be -1. Okay, so everything else should be about the same. Oh! It's kind of starting to work. Look at that. It is now somewhat functioning. Let's go. Alright, we definitely got to play around with some values though and make this a little bit better. Whoa. It's doing something. It is kind of cool. Not exactly working. Are those spirals on the grid? Nope. I don't like how they're getting like stuck on the edges like that. Whoa. Okay. Alright. This looks kind of sick. Not quite correct still. Cosmic web. Yep. We got streams. They still like kind of bounce off the edge for some reason. Ooh, look at that. That is very interesting looking. The randomness is just like not working at all for some reason, and I don't really know why. Rotate random amount. Because if we do 5, it's still just not going to do anything. What is this calculation that I'm doing? Like, what? R times rotate speed times delta time. What is this? Minus rotate speed times delta time. Oh, like, why did it just happen? Whatever. And then rotate angle plus equal to that. Yeah, that's not going to work very well. They're going to be very heavily influenced by randomness. Maybe a little too influenced by randomness. And they're still certainly affected by randomness, but not very much. Whoa. Look at that. That's kind of cool. And then it becomes a ring. I think that means it's working more properly, or no, this is good. This is what poorly drawn infinity symbol. Yes. No, this is good though. This is what we like to see. Man, remember when Oculus existed? Okay. Look at that. That looks a heck of a lot more like the Sebastian Leg video that we were looking at earlier. That looks a lot more like this. All right, so now if we just go ahead and add another one of these things, right? Casual EFPS. Let's go. Woohoo! Very performant, not slow at all. I know, right? This is beautiful. This is exactly what we like to see. Okay, maybe instead of increasing it by a factor of 10, we'll just double it. How about that? We'll try that. Look at that. Alright, well this worked quite well actually. Look at that, we got there in the end. Random. Ah, there we go, that's better. That's what I was looking for. Now it's just a big ring. Whoa! Okay, no, that's kind of sick. Alright, cool. Big ring. We could do multiple colors, but I think we need like a whole new system. Random. Oh yeah, this is gonna go so well. Whoa. It's just exactly the same. You know, well, we can figure colors out someday, I guess. I don't know. But yeah, I mean, I'd say that looks kind of cool though. Yeah, and they're kind of like branching off, which is interesting. I don't know why they're really doing that. I don't know what's going on. Let's see what happens with that. Mind of its own, yep. Well, I'm pretty happy with how this is currently working. I should probably like end the stream. If you'd like to see me make a full regular video about these compute shader simulations or other compute shader ideas, or maybe even in C++, let me know in the comments. Thank you to my Patreon supporters Dennis Fetchner and FluxHD, and to my YouTube members Ulyss, Jen, Zyro, and Miyaki. I hope you all enjoyed this bonus video, and I'll see you all next time. Goodbye.